title of this note sheet says angle of elevation, depression, and word problems. Okay, so really the two words that we're going to use that to describe a situation where we need to use strength and angles is the angle of elevation or inclination. They mean the same thing. So this here, what that is wherever you're measuring it from. Often it's from someone looking at a tall building or a mountain or something like that. Sometimes it's from the ground, just depends on the situation, but it's always from the horizontal upwards. So elevation, think of feeling elevated, you feel happy, you feel up. So you go horizontal up. Elevator goes up, and then students say, well, an elevator goes down. It does. So that's not necessarily the best way of thinking about it. Okay, but horizontal upwards. Angle of depression is horizontal downwards. So if I'm at the top of here, if I'm looking outside and I'm looking down to Mr. I think that's Mr. McKenzie's truck. So my angle of depression is from the horizontal downwards. Okay, so depression starts with a D, down starts with a D. But it's always compared to the horizontal, never to the vertical. Okay, so all of these, pardon me?
You're vertically looking down. What is it called?
Looking down, it's from the horizontal downwards. It's that angle that my arm just moved. That's depression. From horizontal upwards is the angle that my arm moved. Okay, so the acute angle between the horizontal line and the line of sight to an object above eye level, angle of elevation or inclination, and horizontal to an object below eye level is angle of depression. Okay, so in this diagram here, take a look at it. So if, say, we're given the height of that balloon, okay, then that's vertical height. That forms a right triangle. Okay, that angle of depression is not even in the triangle. Okay, so what good is it? Well, what you need to know is that this is a horizontal line, and so is this. And so this angle of depression here is the same as this angle over here. So parallel lines with what we call a transversal going through make these two angles equal. And so then it's in your triangle and you can use it. Or you could subtract from 90 to get this angle, but I don't typically do that. I just use that property that if you have parallel lines, these are called alternate angles and they're equal. Okay, so if a diagram is not given with a question, make sure you sketch one and fill in all the known values. So that's what we're going to do. So to be safe, a ladder should have an angle of inclination about 75 degrees. And if you ever go by a ladder, they're going to have a safety sheet with it, and it will tell you that there's a certain angle that it has to be in order to be safe. Anything bigger, in this case 75, it would be too steep, and it's very likely that if you lean back a little bit, it would force the ladder to go backwards, which would cause an accident. If it's too low, then that's not great either because it's kind of unstable. It's going to slip out depending on what the legs of the ladder are like. So it'll give you a recommendation. So here, let's draw the ground and a building or a wall. Okay, and it says a 14-foot ladder is placed against a vertical wall. So this is going to be my ladder. I can show it with the little rungs there. Okay, it's a vertical wall. It's not some leaning wall. It's not the Leaning Tower of Pisa. It's just a vertical wall at 90 degrees. It's a 14-foot ladder, and it's 3.5 feet from the wall. So, angle of inclination has to be about 75. That is from the ground up to the top of the ladder. So remember we used that Greek symbol a lot yesterday, theta? That's what I'm going to use today for that angle. So we want to find angle theta. So label what sides you have. Compared to that angle theta, this is touching it, so that's adjacent. And the 14 is the hypotenuse. We don't care about where vertically it is on the building. So if we have adjacent and hypotenuse, then take a look at your formula sheet, flip back in your notes, what uses adjacent and hypotenuse? Who wants to tell me? Either? Cosine. Good. So cos of theta is 3.5 over 14. So we're looking for an angle. You get out your calculator. You've checked that it's in degree mode. Let me just check, make sure mine is. It is. And then I go second cos 3.5 divided by 14. Okay. 75, what is it, 0.5. Okay, so really it's pretty close, right? It's not too far off. I don't know what we put on the note there. Yeah, it's safe. It's pretty close. Anything really probably plus or minus a couple of degrees, then it's not safe, but it's 75.5 degrees. So I would say it's safe.
If it was lower than 75, it'd be bad.
Yeah, same deal. Yeah, because it might slip out. Like if you have a ladder that the base of it, they should have rubber, stockings on it, but it might slip out depending on what it's on, slip out.
So what if it's around 75?
Yeah, we'll be specific in a question if we put it on a test, right? Okay. Next one, we also have to draw a diagram. So it says one part of the bicycle pathway along 14th Street in the Northwest. A cyclist travels a distance of 1 kilometer along the pathway while gaining 80 meters in elevation. So the path is going upwards. It's on an incline. Okay. It's gaining 80 meters in elevation, which means the vertical height is 80 meters. So if we were to draw this compared to the horizontal, here's the path. Okay. And so 1 kilometer is the path traveling along it. And then the vertical elevation is 80 meters. And it says determine the angle of inclination of the pathway. So would that be the bottom left angle or the top right angle? Bottom left, from the horizontal up. So we'll call this theta here. And notice, are the measurements in the same units? No. So convert them to the same units. So 1 kilometer is 1,000 meters. Or you could go 80 meters is 0.08 kilometers. Either one. Doesn't matter in this case because your calculator is doing the work. So now label, compared to that angle theta, okay, 80 meters is opposite, and 1 kilometer is the hypotenuse. Okay, so then look back in your notes. What is opposite over hypotenuse? That's not a sin. Sine. You got it right, but we say it's sine, yes. So sine, which is spelled S-I-N as the abbreviation of theta equals 80 over 1,000. Okay, remember that's not your final answer. You're trying to find the angle, so you don't have to reduce it. So now your angle is inverse sine of 80 over 1,000. I forgot to put forgot to put theta up here. This is cos, sorry, I forgot to show that work on the last one. Okay, so that's what it looks like in your calculator. I'll use my Casio this time. Okay, so I'm going to do shift sine of 80 divided by 1,000. Oh, I need brackets in the Casio. Just a sec. Okay, so shift sine bracket 80 divided by 1,000. Close bracket, enter. Okay. 4.588, whatever it says, nearest, what does it say? Nearest hundredth. So 4.59. Because we're calculating an angle. So angles always is the second or shift key. You're doing the inverse operation. We have to get rid of this sign.
On the first question, do we ask, so on the first question, we're not looking at angle.
Yes, we are.
Oh, first question we were.
Yes. 53.1? No. Yeah, it's 80 over 1,000. It should be pretty small because it's an angle of incline on a pathway, right? Okay, so we're going to skip question 3 for now. You're going to do that as a group in a few minutes. And now we're going to go to question 4. Okay. So in question 4, anyone know who Angelina and Brad are? Angelina Jolie and Brad Pitt. This is many years ago, and whoever wrote the question decided to keep it in there. Yeah. In any case, so Angelina in the hot air balloon spots a bag of money on the ground below. Okay, you can see there's a diagram. And so she radios to Brad, who is standing directly underneath the balloon, so vertically underneath. So it forms a triangle, 90 degrees there, and tells him to run to the money bag. If the angle of depression for line of sight is 38, so we've even labeled it. So that means this is 38 degrees, okay? And her height above the ground is 215 meters. Determine how far Brad has to run. So that would be X there. Oops. Okay, now that 38 degrees is not in the triangle. But remember what I told you before. This is parallel to the ground, right? Horizontal. The ground is horizontal. So that angle there is going to be the same as this angle here. Okay, it's called the parallel lines theorem. So you probably touched a little bit about that in junior high. So now I have an angle, opposite side. I'll label it with OPP. And I want to find the adjacent. So which trig ratio uses opposite and adjacent? 10. I've done one of each. So this one is tan, but this one we know the angle. So tan of 38 is opposite over adjacent. When the unknown is in the denominator, do we multiply or divide? What did I say yesterday? Denominator, divide. D. So x is 215 divided by tan of 38. Okay, so just enter it in your calculator like that. So you're not using the second key, you're trying to find a side. So, just a sec. So this will be 215 divided by tan of 38. Close the brackets on that. And that's 275.2. Take a look at the units, and that is meters. Okay. That's where we're going to stop it for now. Okay, so let's turn to the next page. Okay, so it says Mickey is flying a kite in Glenmore Park. At one point, she has let out the entire 156 feet of string that is attached to the kite. So right away, I can label this 156 feet. The angle of elevation for a line of sight to the kite is 54. So we want to do a horizontal line at her line of sight, and angle of elevation is this angle, which is 54. And the string is tight. Taut is meaning it's straight. Okay, determine the horizontal distance from Mickey to the kite. So that means we want to draw a 90-degree triangle, and we have to find that horizontal distance x. So I'm going to label, compared to the 54 degrees, this is the adjacent side, and this is the hypotenuse. So cosine of 54 is adjacent over hypotenuse. And then we solve for x, so it's going to be multiplication. Get out your calculator, 156 cosine 54, 91.7. And that is feet. Okay. Then still within that same question, so same diagram. This is 156. This is 54 degrees. Okay, and it says here, determine the height of the kite above the ground. So that would be this. Okay, except that we have to take into account Mickey is holding the kite at eye level and her eyes are 5 feet above the ground. So basically draw the ground, Mickey, and that's 5 feet. So we want to find y and add 5 to it. So labeling, compared to 54, this is the opposite, and this is the hypotenuse. So that's sine. And again, the unknown's in the numerator, so we multiply. I'll use a TI this time. So 156 sine of 54. Close the brackets. 126.2, and then you'll add 5 to that. Okay. So this was 54. So height will be 126.2 plus 5 is 131.2 feet. Okay, so that's the end. Then it's a practice. Let's go back and do that one that we didn't do. So question 3. So a new tree is planted in the ground. The tree is to be pegged to the ground. So here's our tree. Kind of make it look Christmassy. You should do it in green, I guess. And it's to be pegged to the ground with 2 4-meter long ropes. So that are attached to the tree 2 meters above the ground. So let's say there's a rope and then one over here. Okay, and so attach 2 meters above. Determine the angle of inclination between the ropes and the ground. So basically this angle here. So I'm going to use that Greek symbol theta, and I want to find that angle. Each rope, remember, is 4 meters. So my diagram, this is the hypotenuse and this is opposite. So that's sine. So sine of theta is 2 over 4. So theta equals inverse sine 2 over 4. Remember, we don't have to reduce it because we're not done the question. Okay, so then let me use my Casio. So shift sine, I need brackets, 2 divide 4, close the bracket, I get 30 degrees. Okay, so now we've done that entire lesson and you can do the practice.